Hello, everyone. Welcome to the second part of our first topic in artificial intelligence. In this video, we are going to discuss intelligent systems in general. In the first topic, we said an intelligent system or intelligence encompasses three properties of the mind, which are one, recognition, um, planning, and learning. Those are some of the things that are involved. So we now want to start looking at intelligent systems. Now, we said time and again, we'll keep referring to this as intelligent agents. So any system that exhibits intelligence is referred to as an agent, intelligent agent. So an agent is a system that interacts with the environment. So any system, now for an agent, it should be able to see the environment where it's working in, and it should be able to respond. And as we are going to see later on, some of these systems are going to use sensors to detect their environment and then to detect what's happening in its environment. And it's going to have some actuators or some effectors that are going to perform some action on the environment. Now, let's just look at an example. So in this example, we are going to see some simple robots that are supposed to perform a simple task. So these robots are supposed as they are moving, they're supposed to stick to the black line that is there. So uh, these systems, they are perceiving the environment. They've got to see, as you can see, as it is moving, at some point, the robot has to make a turn. Okay. Now, how does it know where to make a turn? It's using some sensors to check when to check for changes. Then there are motors that are moving the robot forward. So where it has to turn to the right or to the left, that is happening because of the motors. So that is an example of an intelligent agent. So let me just play this again. So remember we said any system that perceives its environment and it has to act. So when it perceives the environment to see the changes, then it has to respond accordingly. So this is an example of a simple intelligent system. So we'll see more as we proceed. Okay. Now, the general architecture of an intelligent system can be shown like this. So on the right-hand side, we have an intelligent agent that is supposed to interact with its environment. Now, interacting with its environment will require or will involve two things. One, being able to see, being able to understand what is happening in the environment, that is perceiving its environment, and then taking some action, responding. So the perceiving of what is happening in the environment is done through sensors. So there will be some sensors, just like uh, in the previous video we are from seeing, we have the light sensors which are detecting the change in the colors on the floor for the robot to understand where it is. Then there has to be some action. Now, in our previous video, the actions are being done by the motors, which are spinning the wheels. So at some point, you are able to see the robot turning to the left or to the right because of the action of the effectors, in our case, the motors. Okay, so we've already said an agent perceives its environment through sensors. So a complete set of inputs is what we call a percept. So whatever it sees is what we are referring to as a percept. Then there is the action. Now the action is an operation that the agent will perform. So a response to what is perceived is what is referred to as an action. Now this action are performed through actuators or effectors. So actuators or effectors, when we mention this, we're talking about the same thing. So in the case of these, we have the motors that are moving that are specifying the speed at which the wheels should be turning. So that is an example of effectors. Now, the agent can have some goals. So as we are going to see, most of these intelligent systems that are built have a goal. Now, the agent will be working to achieve that goal. So there has to be, so whatever decision that is taken, whatever action that are done, they are designed to achieve a particular goal. Now, how should an agent behave? How should an agent perform? So each agent is supposed to perform an action that should each agent is working to achieve a goal. That we've already said that. So now we are going to bring in the idea of a rational agent. You will recall in our session, the first session we had, we did talk about being rational. Now, a rational agent is one that does the right thing, or an agent that a rational action is one that is designed to favor or sorry about that. So we're saying a rational agent is one that does the right thing. So you, as a human being, when you make a rational decision, you are going to choose something that will not disadvantage you. That is a rational decision. For example, if you want to go out and you can see that it is raining heavily, the decision you are going to make, if you are a rational decision that you're going to make, will be one that ensures that you are safe and the things that you have are safe. That is a rational decision. So to determine whether our agent is working accordingly, there has to be some performance measure. Yes, there has to be some performance measure which will tell us, which will help us to evaluate an agent, how well the agent is doing. Of course, there will be different measures. For the line following robot, which we saw, the measure that we're looking at could include things like how quickly it moves around its path. Another measure that we can use to determine whether to determine the performance of our agent is how many times does it fail to follow the path? How many times does it wander off the path that it's supposed to follow? So, of course, this is a point I'm driving to, and shortly we'll see that you won't have one fixed measure that is suitable for all agents. Each agent is supposed to perform an action or to perform actions that are calculated towards it achieving its goals. Okay. So how should agents behave? Let's look at some examples. So in this video, we see a Roomba that's an automated vacuum cleaning system. Now, this system is supposed to clean different environments. So it can clean carpets and it should clean hard floors. So as it is moving around, when it goes to the carpet, for example, it is supposed to adjust the speeds. It's supposed to adjust the rate at which it is cleaning. So now, as it is moving, as this agent is working, you'll notice that it is supposed to identify where there's dirt. So as it is moving, it's supposed to identify where there's dirt, and it is supposed to collect the dirt. It's supposed to collect the dirt. So as it is moving, it is supposed to check where there's dirt, and if it finds any dirt, it is supposed to collect the dirt. And when it finishes, or when it gets to a point, it also has to detect when it finishes or when it reaches an obstacle. So it's supposed to do all that. So this is an agent. Now, remember we talked about how do we measure the performance of such agents. So one measure we can use, for example, for this particular robot is how well it cleans the carpet. We can also look at how well it adjusts. So when it is, for example, so like, as you can see, when it gets to a point where there's a cliff, how well does it detect that there's a cliff and moves away? So that's something which we can look at. So for this agent, we've looked at the amount of dirt it can clean up, etc. We can also look at things like the amount of noise it generates as it is working. So here we are looking at how do we measure how well an agent is performing. So that's the idea. Another agent that we'll look at is an automated car assembly system. Okay. So here we have an automated system that's supposed to assemble a vehicle. So from the chassis of the vehicle, as it is moving along, this entire system, the entire factory, is the agent that we have. So it is the agent is supposed to detect when there's a vehicle chassis, the body of the vehicle, and then the agent is supposed to put the screws to the bolts and the nuts. It's supposed to put them in the appropriate place. The seats and actually basically all the parts of the vehicle. It's supposed to connect. It's supposed to put them there. So it would as the body of the vehicle is moving, it is supposed to put all the necessary features of the car until finally we have a vehicle. Now, such a system also qualifies to be an intelligent agent. So the agent has to perceive where the car is, and that's the positioning of the car, so that the robot hands can put the appropriate fittings to the car. All right, so that's the same thing we're talking about. Another agent we'll look at is this one that's supposed to pack some snacks. So in this agent, as you're going to see, it's supposed to pack salami sausages. I hope that's the correct thing. Yeah. So it is supposed to detect the sausages on the conveyor belt. So these are the sausages as they are moving, and as they are moving, the robot is supposed to detect when there's something to pick, and pack them accordingly. So let's see what happens. So these are moving on a conveyor belt. Okay, sorry about that. Let me just see what's happening. Sincere apologies. I think there's something wrong with my video. But basically, what this one is trying to do is to pick these sausages and pack them properly properly. So as they are moving, supposed to do that. But unfortunately, this particular video is not complete. So let's look at something else. I'm sincerely sorry about this. Okay. The last agent that we'll talk about is a self-driving vehicle. Now, a self-driving vehicle, it has a goal. So it's supposed to move around to take people from one place to the other. Now, as it is moving, some of the things that it has to do is, one, it is supposed to know where it is in the environment. So it has to perceive. If we use this vehicle, for example, to move from Kitwe to Lusaka, let's say the self-driving vehicle, it's supposed to know when it has reached Kabwe, when it has reached Lusaka, when it gets to the destination. So as it is moving, it needs to know where it is. So it will use things like sensors. Okay, it will use things like GPS locators, etc., so that it knows exactly where it is. And as it is moving also, it's got to know the things around it. Are there people around it? Are there stationary vehicles? It also has to know when to turn. It has to know when to overtake, etc. So there will be the issues of um, being able to perceive its environment, as well as being able to make the right decisions. So for such a system, we have, for such a system, the actuators will be the motors again that will be moving the vehicle, whether to turn to the left, to right, even the horn, so that it can alert people if there's anything in the way. So even for this one, as we look at it, if it's a rational agent, a rational agent is supposed to perform actions calculated to achieve the goal. So the intended goal of the vehicle, for example, is to reach the intended destination. So for us to measure how well this agent performs, we've got to look at things like how many accidents does it avoid? How quickly does it get to the destination? So those are some of the measures that we can use. All right. So we've given examples of agents so far. We can also have software agents. Remember in the previous video, we did look at the Grammarly software. We also have today chat bots and chat bots and things like Chat GPT. So all those are examples of software agents that we now have. We also have intelligent buildings. So each of those agents, and like we said, agents are supposed to have a way of getting input, perceiving the environment, and responding accordingly. So those are the fundamental faculties of intelligence. One, acting, so sensing. When it senses, it should understand, reason, learn, and finally act. So that's that. So we said an agent must be rational. And remember, labor to talk about being rational. Now, rationality, perfect rationality. Now, perfect rationality means the agent knows everything and it will take the action to maximize its utility or to maximize its action. Now, perfect rationality, meaning the robot or the system doesn't ever make a mistake. Unfortunately, just like human beings, we are not perfectly rational, or the decisions that we make are not perfectly rational because we have limitations. Limitations could come in the form of limited information. So we don't know everything. We have limited information. But with the limited information that we have, we make a choice. We perform actions that are calculated to achieve the goal. So even with the limited information that we have, we are going to do the best that we can. So bounded rationality is the concept that we were talking about, because the agent is not omniscient, it's not all-knowing, so it will try to optimize as much as it can. It will perform the actions that are right. So that is what bounded rationality is all about. Now, let's talk quickly about the environment where the agent will perform or will work from. So, in talking about the environment, we can discuss the environment from a number of aspects or perspectives. So, the first one is observability. Now, the agent can operate in an environment that is fully observable or partly observable. In a fully observable environment, all the environment, all the everything that an agent needs to make the decision is fully observable. It can see everything, every part of the environment. For example, when you are playing chess against a system, an intelligence system, it is able to see the entire chess board. That is its environment. So it can see all the pieces, all the pieces on the board. So such an environment is fully observable. Now, some environments, not everything is visible at all times. Some of the aspects of the environment are not visible. For example, for the self-driving vehicle, its visibility is limited to a certain to a certain area, or at a certain radius. Okay, so when you are driving, for example, when the vehicle is moving from Kitwe to Lusaka, okay, it's only able to see a few hundred meters in front of it and behind it, in front of it mainly. So let's say as it is approaching the junction, what is coming on the left or on the right, it is not able to see. So it's only able to see a few things. So not all the information is available. So as we look at the agent later on, when we talk about developing these systems, you've got to think about where your agent is going to operate from. Is it going to be in an environment where it can see everything, or it will only be able to see part of the environment? And as we think about this, we are now going to make decisions, or we are going to develop systems so that we are not unfair to the agent to say it's not performing well, or we design a system that we're going to design a system that that performs well given the limitations. So observability is one issue we need to look at. The other issue that we need to look at is the environment deterministic? Now, in a deterministic environment, the next step, the next state of the environment is completely described by the current state and the agent's action. So we are saying when the agent is in the current state and it performs a particular action, the next environment or the next state of the environment is known. For example, when the agent is playing chess, okay, and it captures the next piece, it captures one of the pieces, it knows what else has remained, the other pieces that have remained in the environment. Okay, so that is deterministic. So the next action or the next state of the environment is determined, completely determined by the current state and the agent's action. So it knows that when it does this, this is where it's going to land. This is the next step, next state it will move to. Other environments are stochastic in nature, meaning there's an element of uncertainty. So the agent will perform its action, but there's always an element of uncertainty. It's not always that when it performs action A in state A, then it moves to state B. There could be some element of uncertainty. I hope that makes sense. Another way of describing the agent is whether it is episodic or sequential. Now, episode. For those of you who are into watching movies, TV, etc., there are some TV programs where what happens in a particular episode has no bearing on what will happen next. So you find that each episode is independent of the other. So in an episodic environment, what happens in step one, in episode one, has no bearing to what happens in episode two. So for an intelligent agents that operate in episodic environment, it means what has happened in this part of the environment has no bearing on what happens in the next part of the environment. However, there are also sequential environments. Now, in a sequential environment, what you find is that the environment, like there's this continuation of episodes. So you find that from the first step to the next part of the environment, all these are linked. So in the episodic environment, there's that disjunction, that disconnection. First episode, independent of the second episode. In the sequential environment, you find that there's this connection. We can also describe intelligent agents in terms of whether the environment changes or not while the agent is working. So we have dynamic environments and static environments. In dynamic environments, you'll find that the environment is changing independent of the actions of the agent. For example, if we look at the self-driving vehicle, as it is moving in the environment, there are other agents, there are other elements of the environment that are changing, and their change is independent of what is happening to the vehicle. So as it is moving, you find that there's a cyclist who is also riding their bicycle. You find that there are vehicles that are coming from the opposite direction. There are other vehicles that are also moving in the same direction. So you find that the environment is constantly changing, and some of the changes, these changes are not as a result of the actions of the agent. No, they are independent. So that's a dynamic environment. So other environments are not dynamic, meaning they are not changing. They are not changing, so they are static. They are static. They are just the same. So the only thing that will change as the agent changes, as it is moves from one part to the next, then its action is what will take it to the next part of the environment. But then dynamic environments, you'll find that as the agent is making its movements, there's that dynamism, there's that change that takes place. So we've got to, the agent has to take care of that. Now, the other aspect of the agent's environment is continuity. This is similar to what we said about episodic environment. So continuity, here we are looking at if the number of distinct percepts and actions is limited, then the environment is discrete. So here we are saying uh, the inputs are limited, so, and they're coming at specific times. So for example, if we think of a chess playing agent, you'll find that the specific actions are quite limited. So if it's, yeah, like there are about 8, 9 pieces, different types of pieces on a chessboard. So each one, the actions are quite limited. So for such an environment, we say the environment is discrete. Otherwise, the environment is said to be continuous. The other way of describing an agent is whether it will operate in a multi-agent environment or a single agent environment. So the presence of other agents. So for a single agent system, it means it's the only agent that will be there. There will be no other agents in its way. So if we look at the Roomba the cleaning robot, you'll find that it was operating in an environment where there were no other agents there. But there are other systems that will operate in a space where there are other agents also operating. For example, the vehicle assembly system. For the vehicle assembly system, you'll notice that there wasn't just one robot hand, there were several. So each agent has to bear in mind what the other agent is doing so that there are no crashes in the environment. Okay, so let me stop here. The next part, we're going to look at how do we classify these agents. So I'm going to stop this and immediately, and we'll continue shortly with the next part. Thank you very much for watching.